What's good, Logan? This video is for Miley. So your question is, how do you do line of best fit? First thing we need to understand is what is the line of fit? Not best fit, sorry, line of fit. Line of fit is just an approximate line that represents your points on your graph. So best thing for you to do is start off by drawing a line that represents these, what is it, 1, 2, 3, 4, 5, 6 points. So, kind of like that. And then you're like, that doesn't really represent. Okay, exactly. You want to make sure that when you draw your line, you're doing a really good job of kind of representing those points right there. So I would say kind of like that. I think that's a really good line of fit there. Now, some of you might argue and say, no, the best line of fit looks like this. Okay, here's the thing. We all can show up with different answers, but most of us are going to pick a line that kind of looks like something in here. Very few of us are doing this. All right, very few of us are doing this. We're kind of picking something in this range right here. I'm feeling that's my line of fit. Now, after you've created your line of fit, the next thing you're going to want to do is find 2 points that are on this line. Because now what we're trying to figure out is what is the equation of the purple line. I don't want to know the equation of the red dots. I want to know the equation of the line that approximates the dots. Not exactly as those points, but the approximate of those points. So I'm going to look for points that I can identify. I can identify that point right there. Now I get to decide how accurate I want to go with this point. So this point is 10 units to the right, and it's 9 units up. So I'm going to call that point at 10, 9. And then I'm going to pick another point right about here. Okay, now I have an option for this guy. So if I zoom in, some of you would be like, yes, that is located at 20, 4.8. And now I'm thinking to myself, why would you do that? Not 4.8, sorry. Oh my gosh, I've made some big mistakes. All right, mistakes were made. So that 10 is 9 is not 10, 9. That's actually 10, 14. That's my mistake right there. That's number 1, 10, 14. Sorry about that. And then this guy over here, this point, some of you are like, so 10, 14 is more accurate than 10, 9 by a lot. 10, 9 would be like here, okay? Now this point right here, I'm going to call that point 20, 10. Now, some of you are like, but no, if you look really close, it looks like it's a little bit less than 10. Why would you give yourself a decimal? Approximate it, right? So we're approximating this thing right here. I'm going to approximate it at 20, 10. All right, step 1, draw the purple line. Step 2, find 2 points on the line. Step 3, you need the equation of the line. To write the equation of a line, what you want to do is find the slope first. So we're going to use the slope formula. M equals, we're going to take our y values, 14 and 10, and we're going to subtract them in the order that we read, 14 and 10. So we're going to go 14 and take away 10. Next, I'm going to go in order of the x values starting with 14's buddy. So 14's buddy is 10. So I'm going to go 10, take away 20. All right, now we got to do some it's arithmetic. Now we got to do some math. We're just going to go 14 take away 10 is 4. 10 take away 20 is negative 10. And we now have a slope of negative 2/5. Negative 2/5. Now, if you want to write, or if you want to write it as a decimal, you can write it as negative 0.4. That's up to you. I don't like decimals, so I'm not going to be using that decimal right there. All right, step number 3. After you draw the purple line, find your 2 points. Step number 2 is find your 2 points. Step number 3, figure out what your slope is. So we found out our slope. Our slope is negative 2/5 or 0.4 with a negative in front of it. Next, what you're going to do is you're going to use the point slope formula. The reason we're going to use point slope is because I didn't give myself the y-intercept. If I gave myself the y-intercept, I would have used y equals mx plus b. But I didn't, so I'm going to use y minus y1 equals m times x minus x1. Now, my slope is already known to us. We already found it. It's negative 2/5. So I'm going to put a negative 2/5 right there. The x and the y are not variables, are variables, and they're not going to change. They are variables dependent upon each other. And then I'm going to put my y1 and my x1. I need to pick. Am I picking 1014 or 2010? I'm a big fan of 2010, so I'm going to pick that one there because they're both divisible by 5. Kind of a nice quality of those numbers. So I'm going to take the 10 and I'm going to subtract it from the y. And then I'm going to take the 20 and subtract it from the x. And this is the equation of that purple line. But we're going to simplify it to make it look pretty. So we're going to go y minus 10 equals, distribute the negative 2/5. So we have negative 2/5 x. Negative times negative is positive. 20 divided by 5 is 4, but multiplied by 2 is 8, so plus 8. Then I'm going to add the 10 to both sides to get the y by itself. Oh my gosh. Beautiful. We have y equals negative 2/5 x plus 18. But that 18 makes so much sense because this looks like it would have been 18. So had I just picked 18 comma 0, nope, 0 comma 18, I would have had my y-intercept very quickly. So what is the answer to the line of fit? It is the purple line given by the 2 points on the purple line with the slope of negative 0.4 or negative 2/5 that comes down to the equation y equals negative 2/5 x plus 18. This is how we do line of fit. If you were doing line of best fit, you just throw it in the calculator. Desmos does its magic, and you get an equation with a correlation coefficient. Notice that the red dots are not all on the purple line. What that tells you is that your R is definitely not -1. If R was -1, it would have that slant in the negative direction, but all those red dots would have been on the line, which it is not. So our R is not -1. Those dots are fairly tight, so I would make the assumption that R is somewhere along the lines of -0.89, something like that. I have no idea what the actual value is, but that's what I think the correlation coefficient is. That last bit of the correlation coefficient, that's just kind of pushing the idea. Really what you want to do for line of fit is understand how to write this guy here, that equation. It starts with drawing the purple line, finding those 2 points on the line, then figuring out the slope, then using the point slope formula with one of your points to write the equation. All right, I wish you guys the best of luck on studying tonight, and I'll check you guys tomorrow.